So we will be as fast as we can. Unless you have a question, I will just show and map the similarity. Okay? So we're done. Two effects A and B are independent if the effect satisfy this relation. We have seen in chapter 1, we have seen examples. Now when we move from events to random variable, we say if x and y are two random variables, they are independent if for any subset A and B of real number. So A is a subset of real numbers, B is a subset of real numbers. If this is the case, then A and B are independent. If this event and this event are independent. Under that circumstance, what we can write? The probability that x in A and y in B, joint probability will be equal to the product of their individual probability. So these two equations are identical except the fact that here A is an event, here x in A is an event. Here B is an event, and here x in B is an event. So both of these two are identical. In chapter 1, we consider events for chapter 2. Now we will consider negatives. And when this one is true, we can immediately write this one. For any real numbers, if this is true, then x and y are independent. If the probability that x is less than equal to x and y is less than equal to y, the joint probability will be the product of their individual for any two real numbers. By the term for any two real numbers will be whatever point you set on the 2D plane, xy plane, this relationship has to be true. And what is the next simple extension of this one? Two random variables x and y are independent. If for any points x, y on the 2D plane, this relation is the joint CDF is equal to the product of the individual. That's what we have. Now, when we move on to discrete random variable, this irrespective of the type of the random variable, whether the random variables are discrete, whether the random variable is continuous, this CDF relation is true. But now when we move on to the case of discrete random variables, then x and y are two discrete random variables with set of possible values s of x and s of y. Then they are independent if and only if for all x in s of x, for all y in s of y, or you can write for all x, y pair in is a set. The events x is equal to x and y is equal to y are independent. If they are independent, then x and y are independent. Which actually results in this line. The probability that x is equal to x and y is equal to y will be the product of the individual probability. And eventually we can write the joint BMF of two random variables is equal to the marginal BMF of product of the individual marginal BMF. And this condition should be true for all x in S, for all values of x and for all values of y. So it has to be satisfied for all values. Or we can consider all values. Furthermore, what we can also consider, if x and y are independent, then this relation is also true. I think we can recall this one. Right? If A is independent of B, then the condition probability of A given B is equal to probability of A. That means knowing that B has occurred does not change the probability of occurring given cell. Knowing that Y is equal to Y does not change the probability that X is equal to X. So the probability that X is equal to X is same as probability that X is equal to Y given that Y. So X is equal to X given that Y is equal to Y. So this conditional probability becomes the unconditional probability when random variable X and Y are independent. So this simple condition is. Can we solve this problem? So suppose that a ball, we have 40 balls in a box or arm. 10 balls are red, 30 balls are. If we first pick 13 balls with replacement, and then after a pause, you pick 20 balls without replacement. Right? Now, find the probability that if pick 4 red balls among the first 13 balls and 7 red balls among the next 20 balls. Can you calculate this probability? The first one is X is the number of red balls among the first 13 balls. Y is the random variable that represents the number of red balls among the second 20 balls. Then A, what is the distribution of X? What is the distribution of X? You know, okay, what is the distribution of X? Okay, whenever you are picking 13 balls, right? Each of the ball picking is independent to the other. Like that is in type with replacement. Suppose percentage. Without replacement will also work. Since the solution comes as with replacement, the replacement will also work differently. So if they are with replacement, the next is then that constitutes a Bernoulli triangle, and we are counting the number of each red ball in the success, and X is right. How many? 13. And what is the probability that it will be a red ball? 1/3. Out of 40 balls, there are 10 red balls. And Y is low. Also binomial with 20. And we need to find the probability that what? This one. X is equal to 4 and so this requires joint PMF of X and Y, right? So can we write the marginal PMF of X? What is it? Marginal PMF of Y? Do I need to fill up this? Then what is the joint PMF of X, Y? Are they independent X and Y? Right? Then right? Yes or no? Joint PMF is the product of the marginal. 20 choose 7. 1 over 4 to the power 7. 0 over 25. This can be generalized. But n choose x, n choose y. P to the power x, 1 minus p to the power n minus x. P to the power y, 1 minus p to the power n minus. This can be combined together. Right? Yes or no? If x and y are two independent random variables, then for real valued functions, then for real valued function, value is what? Value of the random variable is converted into another value. So we have actually two random variables. We can consider W and C. If x and y are independent, then two random variables derived from x and y will also be, because x depend on x and W are related, y and z are related. So if x and y are independent, then W and z will be independent as well. If x and y are two independent random variables, then for a real valued function, this one, their expected values will be product of their and the special cases. So if x and y are independent, then the expectation of their product will be equal to the product of their. What is this? The correlation will be, this is the correlation of x, y. I will define it. The correlation of x, y will be the product of their individual variable. However, the converse is not true. Meaning, if two random variables are independent, their expectation is the product of their individual expectation. But for two random variables, if the expectation, the product of their individual expectation is equal to their, the product of their is equal to the expectation of their product, they may not be independent. Is it clear? It works only in one relation. If they are independent, this relation is true. If the relation is true, they may not be independent. Independence of continuous and same thing. We conclude that for all values of x and y, what will happen? The joint PDF is equal to. So we can summarize it. For events A and B, it will be equal to probability of A times probability of B. For discrete random variable, the joint PMF of xy will be equal to their individual PMF. For continuous random variable, joint PDF will be equal to their marginal PDF, right? Okay, focus on this problem. Suppose that there are two paths, A and B, between two computer nodes in the network. This is path A, this is path B. The PDF of the millions of packets in hundreds of microseconds. So when it says 1, it means what? 100 microseconds. When it says 3, it says what? 300 microseconds. It can be anything. But the two paths is given by this. So for both the two paths, the PDF is set. Now, if the package delay of one path is independent of the other, one delay of one path does not depend on the other. Find the probability that for two packets sent in two paths, the delay of one path is at least 50 microseconds more than the the probability that the delay in one path will be more than the delay of the. Can you do that? Do it. What do we need to calculate? Calculate what? What is given? If we consider that x is the delay of path A and y is the delay of path B, then delay of x and delay of y are same. That is x by 4 and y by 4. Right? X by 4 and y by 4. Now, what we need to calculate that the joint medium. What is the joint medium of x and y? Can anyone calculate it? Joint medium of x and y? What will be the value? For x the value is x, for y the value is y. X equals 60. So from the joint medium, let us consider the joint medium is defined. This region. In which region the delay of one path will be 50 microseconds more than the other path. Oh, sorry, my mistake. My mistake is here. X and y are defined for this, right? From 1 to, for which region the delay of one part will be 50 microseconds more than, and this one indicates what? 100 microseconds, right? Because instead of writing 100, it is written 1. Instead of writing 300, it is written, as we mentioned, that in 100 microseconds. So 1 means 100 microseconds. So, which part of this curve indicates the delay of one path is 50 microseconds than the other? Can anyone draw? So, what is this line indicates? Right? What does it indicate? The shaded region indicates x is at least 50 milliseconds greater than what does it indicate? So what we need to calculate is probability. Right? The probability that we need to calculate is either x is greater than y plus half, or the probability is that y is greater than. Both of these are identical since the distribution of x and y are same. So can we write this? Yes or no? So this region actually is this region. How can we calculate this region? The probability density is not same. You need to integrate it. Just multiplying is not enough. Why? As x increases, the density, because it is x by x by 4. So as x increases, the density also increases. So calculating the area and multiplying with the probability density will not. You understand? Calculating the area and multiplying with the area will work if and only if density is x and y both change are changing. PDF is also changing. Now it is xy divided by 16. Okay? So how can we do that? We need to, what do we need to do? To find this one, we need to calculate the joint PDF of x and y. Once you have the joint PDF of x and y, the probability will be what? 2 times the joint PDF dx dy or dy dx, depending on so can anyone tell the limit? What is the limit of x? What is the limit of what?
0.5 to 3.
So y goes from? If we are focusing here, right? We are not calculating this one. We remove the upper one by what? Since both of these two are identical. So for this part, the lower one, bottom one, if y goes from 0 to what? 2.5, right? And then x goes from
1.5 to 3.
Why does the
up to?
3x.
Okay, this is one. Let's see what the book has done. Y is the inner implication, x is the outer. So we set the value of x. So what is the limit for x? It starts from here.
X minus 1 by 2.
Is 3 by 2. 2 what?
3.
So, right? And for each value of x, y goes from?
Second thing. 1 to x minus 1.
From 1 to? Right? When x is this one? Are you okay with that? And the result is right. We are done. One thing I forgot to include for there are many things in this chapter. So one thing that I forgot to include is actually Bayes theorem. Bayes theorem that we have learned for events can be extended for both discrete and just illustrate of bi given a, it will be y is equal to y x, something like this. We'll try to show you an example of Bayes theorem later on, since it is not here. Discussing this one will waste time. So we will for now leave it. Right? Any questions before we finish this chapter? How many slides? A very small chapter, right? Only 61, very small chapter. The class is not finished. Okay. If you somehow are the class is finished, it is not the case. We'll try to finish or at least scan through the slides. How many slides are here? Can you see?
Scroll. 65.
We'll try to fly. the title of the chapter. This part, majority of the slides are on this part. But due to shortage of time and it is not in the syllabus. Okay, even this random history is not in the syllabus. But once again, even the random features are not in the syllabus. But given the current context, that you will deal with data. So a huge amount of data, right? Not only your advanced courses, but also in your real life. So both these two topics are very important. Why? You will not actually, most of the cases, you will be dealing with situations where there are 100 random variables. Thousands. They're actually random variables x1, x2, x3, x100. It's not good, right? Vector is equal to x. And we forget how many components are there. It could be a dimension of vector, equal to 100,000. And the second thing is that most of the cases data tend to have Gaussian distribution. This is one. The second most important thing is once Gaussian, always Gaussian. Minimum. If you have two Gaussian random variable, there will be. If you have the conditional distribution of two Gaussian random variable. So once you start with Gaussian, then whatever they do, you will end up with. Yes, actually make the mathematics practical. Otherwise, when you have n random variables, just consider that probability of A, B, C, D. What is it? Probability of A, then B given. Probability of D given. Right? So if there are hundreds, D given A, B, C, D up to 100, right? So calculating this probability is always difficult. But here, since it is Gaussian, whatever you do, there will remain as only thing that you need to know is what? What is there? Mu? And one thing is that once Gaussian, always Gaussian, and once it is Gaussian, actually the two unknowns are. So this makes our life very easy. And tractable mathematics are there. Post-known solutions are there for Gaussians. Why? But we started with Gaussian with the assumption that Gaussian CDFs cannot be calculated. Right? How it is tractable? Actually, somehow what we do, we end up with this one. What is this value? If you can reach here, you can replace this one by. If you have this one, this one equal to? That actually made our life. You need to rearrange the map in such a way so that you can calculate this one. And since this one is 1, always the mathematics is tracked. Okay. So let us begin with vector notations. It is not our job, just to remind you. We will consider a vector. Right? That means whenever you have a mathematical formulation, you can solve it in some place where putting the values of the variables you can get the right? But when it is not tractable, then actually you are somewhere, then you cannot get that, right? For example, when you are given the Gaussian period, instead of from minus infinity to plus infinity, if I just increase it by x, you are done. Right? And you need to go for the table. Table is actually you need to go for the numerical solution. What we do? We use the other way around and we check for all possible values whether this one messes with the equation or not. Then there are techniques we learn in the subsequent system. So what is a vector? Vector is something that is not a scalar, right? What is a vector? Then, so vector.
The ordering and decreasing terms.
What is it?
It's a point in n dimensions.
Huh?
A point in n dimensions.
Point?
In n dimensions.
Point in dimension. So this point is a vector. This point is the vector or this line is the vector?
The line.
This DQ line is the vector. Have you read the book of Gilbert Stuart? What is the very first sentence of this book? You cannot add and factor in any elements. You cannot add and apple and elements. Okay? But if you have a box with some apples and some oranges, if you can add with one such box and another such box, you produce, if there are 2 apples and 3 apples there, then you have the sum is hybrid. This is actually mixing things that are not related together, right? And keep them separate, orthogonal. Then actually such a list is there. Here actually it represents whatever you represent in the x direction, whatever you represent in the y direction, this tells you how many of this, how many of this. That list is there. Anyway, we will consider vector is not our job. Our job is what is a random vector? So vectors actually have components. Each of the components represent the independent things that are part of it. For example, you can have apple in one direction, orange in that then the basket represents the vector of apple and orange. Now, in case of a random vector, what we have? The components are if the components of a vector are random variables, it's better not to keep the commas here. Then we call this x. The underline one indicates a bold face letter. Just to separate it. So this x and this x difference is lower one is bold face. Actually marking this one is looks odd, that's why. If I write here any bold face letter, then it will be underlined. But text actually have underline. For example, this one is a vector. We represent vectors by boldface letters. Then x actually is a column vector. We will always consider the random vectors as column vectors. For example, x1, x2, xn. And we will assume there are n vectors, n component vectors. Now, representation of column vectors actually in text is very what? It wastes space in the page. That's why instead of writing this one, we will actually represent the vector transpose of the row. But in reality, it will show. And what n equal to 1? This is simple as one. Sample value vector. What does it mean? So far, whenever we have the probability models, we have two things. One is what? X. Representing a what? Random variable. And a small x representing a value, right? A sample value of the random vector. So whenever we have a random vector, we will have a sample value vector. For example, this small letter, bold plus x, is the x1 is the value of the random variable x1, x2 is the value of the random variable x2, and xn is the value of the random variable, and we have a transposition, right? So now we have two things. One is the random vector x, another one is the sample value vector. Both of these two are models, right? Is it clear? Now probability models for random vectors. Everything is non-positive. The CDF of the random vector x for the sample value vector small x is what? Probability that x is less than equal to. Do you understand this? The next one actually is more understanding. But this one, in fact, this one is more understanding. Is what? Probability that first random variable x1 is less than equal to x1 and the 10th random variable is less than equal to x1. So, the joint probability or multivariate joint probability that we have established for n random variables is same this one. That's why we can represent this one even in this way.
Sorry, random vector is function like random variable.
Sorry?
It's random vector is function like random variable.
Because random vector explicitly represents the joint probability model of n random variables. It is not function. So we do not, whenever you call a function, then for this vector, you need to define whether the other x are x1 plus x2 or x is x1 minus x2. We are not providing such relationship here, right? Here we are telling that x is a collection of vector and the probability of x represents the multivariate joint probability of all random variables, right? If there are three random variables in the vector x, then the CDF of x is same as the joint CDF of x1 to x3 for the value x1 to. Is it clear? So whenever we have a vector, that means it's a collection of random variable, and the probability model associated with the vector is the joint probability of all the components. If there are two random variables there, then it will be joint variate, joint CDF, or joint variate. If there are three, then it will be multivariate, joint variate, multivariate, joint CDF, multivariate, joint variate. Right? For example, in case of the PMF of random variable, random vector x, it is simply x is equal to x. That means the components x1, component variable x1 has the value x1, x2, x2, and x. We understand this or not? Yes? And similarly, this indicates joint CDF of x1, x2, and x. Now, if you have two random vectors,
So we could joint CDF or PDF.
which one? This one?
Sir.
This is video, PDF. Multivariate joint PDF. Now, if you have two random vectors x and y, what will be the joint PMF of x and y? It's simple. PMF of x and y, what we can do x and y. We understand that this x is a vector, right? How many are there? Y is a, how many are there? Y? M. We don't actually force them to be equal size. And then x is x1 to xn, y is y1 to y. Then the joint probability model of x and y simply will be the probability model of how many random variables? That's what it is. The joint PMF of x1 to xn, y1 to ym with values x1 to xn, y1 to y. Is this clear? Similarly, the joint PDF is this one, joint CDF is this one, or two random variables. Solve this problem. Joint PDF of, but the PDF of the random vector x is given by this equation, right? What do we need to calculate? Oh. What do we need to calculate? Oh, what is the CDF of x? Do it. And the vectors x is defined as a way so that values are sample values are always good. This is going to get very good. So can you solve it? So how many how many component random variables are there? Huh? How many? N equal to what? Since the vector A is defined, right? Then x is also three-dimensional, right? Then A transpose x is and it is we can write that right equal to what? 6 into the power, any volunteer? For x1, x2, x3 greater than 0. It is otherwise. Am I right? Then what is the CDF? How can we calculate the CDF? If we know the joint CDF PDF. Right? Can you do that? Integrating, actually this quantity is what? Right? Then, with respect to x1, these two are.
Constant.
So integration of this one will be what?
Minus to the power minus 1.
Minus e to the power minus
X1.
from 0 to
Infinity. Infinity was
when it is infinity, it is 0. When it is 0, then it is
minus 1.
1. Then
0 minus 1.
So why
how? We cannot go. We are calculating the CDF, right?
X.
That's why 1 is coming. You will end up with the value what? 1. If it goes up to infinity. And then actually we will have dozen units, a million. In case of the multivariable, second multivariable, multivariate distribution, from this CDF we calculated what? The PDF. Now from the PDF we are calculating the independent random vectors. If x and y are two random vectors and they are independent, then we just have seen it. If it is for two random variables, it will be applicable for n random variables. So if x and y are independent, then the joint PMF of x and y will be the product of the individual PMF of x and y. And for continuous, it's clear. We also have solved this problem. Random variables y1 to y4 have the PDF equal to this. Another check. Hey, monthly of salary so if he needs the so the joint PDF, multivariate joint PDF of y1, y2, y3 and y4 is 4. Meaning it is uniform. Now we define two vectors. One is V equal to y1 and y4 and w. So this is the vector, this is the vector. Is equal to y2 and permanent. Now question is, are V and W independent? Yes? How can we find that? Is the question clear? Hey, do we give it up? Is solving. Can you help us?
Okay.
So we want to know that V and W, two random vectors, are. To know that, we need to prove that what? The joint PDF of V and W for the value V and W, this relation W should be satisfied, right? The joint PDF will be equal to the marginal PDF of random vector V and W. Question is, how can we calculate this? Someone can tell me, what is this? Joint PDF of? This is the joint PDF of? Right? calculation of the joint PDF of actually when we have here, it is not the joint PDF, it is marginal joint. From out of 4 random variables, we are marginalizing 2 random variables. To get this one, what we need to do for all values of we need to with respect to y1, y4 is here, other random variables, right? What are these? So now only challenge is setting the limits. So what will be the limit for y2?
y1 to 1.
Given a particular value of y1, what will be the limit of y2? That depends on how y1 and y2 are. If we draw the diagram of y1 and y2, then we see y1 and y2 both go from 0 to, but y1 will be always less than. So we are there. Once we are here, for a particular value of y1, y2 will go from. That's why the first limit will be, sorry, the inner limit will be for y2, it will be y1 from 1. And then we have 4 dy. Now for y3, for a particular value of y4, how do they relate y3 and y4? Once again, y3 is less than y4. Then for a particular value of y4, y3 will be from 0 to and it will be equal to 4 into 1 minus y1, and when we will be doing it with respect to y3, y4 will be automatically 1. So it will be 4 times 1 minus y1 times y4. Let us check. As we know, v1 is y1 and v2 is right. Now we have actually the PDF for B available. Similarly, we can calculate the PDF for W. Just from the text I copied it, and I have shown how to calculate the PDF of random vector V. So you can calculate the PDF of random vector W. And what is the joint PDF of V and W? It is given. So the question is, are they independent? To know that, what we need to do? We need to multiply this. Multiplication of this produces this one times this one, which is this one. On the other hand, the joint PDF is what? Are they same? No. If they are not same, who understood this? You? Is it okay? You understand it? Yes or no? Yes? So which part is the problem? So if you do not understand it, you understand this? Joint PDF of y1, y2, y3, 4 is this. We solved this problem before. And we define a vector V which actually has 2 random variables. Which one? Y1 and so V actually you can consider has 2 components. One is V1 and the other one is V1 is related to Y1 and V2 is related to. And then how can we calculate the PDF of the random vector V? How? PDF of random vector V is same as the multivariate PDF of V1 and V2 for the variable V1 and V2, right? And as we know, V1 is related to Y1 and V2 is related to Y4. Then this one is same as this one is same as this one. What we have this is the marginal joint PDF. Then we need to integrate the joint PDF with respect to Y2 and Y3, the other two random variables. We are taking here Y1 and Y4, so remaining two are Y2 and then actually we need to set the limit. We set this limit many times, right? I guess so far essentially is very close. And once this one, then actually we calculate this. Similarly, we calculate this one and the product. This is the most important. Now you understand. You understand? Yes. Anyone? Whose part? We are here. Whose part you remember? However, I cannot start from X is random variable, Y is another random variable. The joint PDF of X, Y is this, right? Then the multiple PDF of X is integrating this one. So all of this stuff actually we have been talking about all of this, right? So then how can I make it understandable for that? So which part you don't understand? Not at all? Sorry? No? Then when I ask you, do you have any questions? Is it just a formality? Every question you ask, I try to answer, yes or no?
Yes, sir.
Then your job is to ask question. And this time I am actually running very slow for today. Some of the classes, I missed 2 or 3 classes and could not actually make up it. And second thing is that I tried to actually go with it. Many times I ask you to solve the problems, right? Otherwise I would have actually finished further topics. And then if you tell me that you do not understand anything, then I am actually very. So what can I do for you? Okay, leave it here. Now, 2 most important topics, terms. There will be expected value of A. Let us first understand the expected value of a random vector X. What will be the expected value? The expected value of a random vector X is very simple. What is it? The expected value of a random vector X is also a vector. If it is a vector, what are the components?
Marginal.
Components is the expected value of each of the random component random. Right? So once you have the random variables, then the expected value will be the a vector which will be the expected value of each of the random variables. So then you need to find out the marginal PMF or PDF for each of the random variables. And then you can, right? Second thing is, what is the covariance of a random vector X? Before going there, just let me we already have learned that it is the correlation between x and y minus what? Right? So if x and y are two random variables, and we also have, now we want to actually see what will be the correlation between correlation of a random vector. The correlation of a random vector is, what is this one? This one is this, right? The correlation of x and y is the expected value of the correlation of a random vector is the correlation of each pair of component. The correlation of a random vector is the correlation of each of the pairs. How many pairs are there? In n random variables are there? N into. However, there is a problem. The correlation of this one is same as the correlation of this is of the way understand. So if we want to represent the correlation of a random vector, then what do we need? What do we need? A matrix. We call this matrix sometimes y. Now, what is the first entry of this matrix? It is the correlation of x1 with. Can I write this one? Then it is the second entry. The second entry is what? Last one? Right? And this one is? So the diagonal elements of the correlation matrix, we call it the correlation matrix, is the second moment of the component. Okay? And also there is a good thing here. The matrix is a square matrix. The matrix is a symmetric. Matrix is a symmetric matrix, right? Now, then can we write outer product of, it is the expected value, but the outer product of the, not the inner product. Inner product, if it is the inner product, then it will be the dot product, right? X and X. But it is the outer product. That means one vector and another vector. So it will be a matrix, right? So now the covariance matrix is, if we focus the covariance of x1 and x and y, then it is what? The expected value of what? X minus mu x times. Can you hold here? Similar to this one, right? What is that one? The xy. Here, it is the expected value of this one and this one. Then, to calculate the covariance matrix, what we need to calculate this vector. Once we have this vector, then the outer product of this vector covariance of random vector x. Let's see. So this is the expected value vector. We have seen it. The covariance is the expected value of this product, outer product of the vector x minus mu x. And this element of this, now interesting thing. If it is the covariance of x, what are the elements? The first element is what? The covariance of x1 with x1. The second element is covariance of x1 with x2. So covariance of x1 with x2 is the variance of x1. Covariance of the same random variables, covariance of the random variable with itself gives you the variance of that random variable. So the diagonal elements are the variance of random variable x1 to x2. What are the off-diagonal elements? The off-diagonal elements are the covariance of xi and x. Here it will be x1, x. Here it will be xn, x1. And once again, if you write this one, then you can write it in this way. This element actually is the expected value of what? X minus mu x whole square. This is the variance. And the second element will be what? Expected value of x1 minus mu x1 times x2 minus and so on. We will in this way. So this is the covariance matrix. Here it is. The covariance matrix of X actually in the as a diagonal element it gives the variance of x1. And the off-diagonal elements are the covariance of two random variables. And once again, the covariance matrix is a symmetric matrix because this element is right here, this element is right here. So it's a symmetric matrix. Are you okay or not? Since we know the covariance of x and y is equal to the expected value of x and y and mu x mu y. We have seen this equation similar to this one. For a random vector, we can write this one. Yes or no? Done. The correlation matrix, we have discussed this one. It is the diagonal elements are the second moment, or diagonal matrix are the correlation between two. And finally, we have this one in place. This is a very good example. And do we know this or not? Here x is this quantity actually is the joint PDF of we have seen this how many times? 100. Now what you need to do? You need to find out the expected value vector of x, the correlation matrix R of x, the covariance matrix C of x, or the random vector x. To do that, what we need to do? We need to find out the marginal PDF of x, right? Marginal PDF of x is the integration of joint PDF of x with respect to x2. And if this is x1, if this is x2, For x1, what is the range for a particular value of x1? What is the range for x2? 0 to x2, right? 0 to x1. 0 to x1. Otherwise, it will come as a value of x2. 0 to x1, right? But you know it. And also you can calculate it. For x2. Once you have this one, right? Make it question. x1 to 1. The diagram is, that's why for a particular value of x1 is from x1 to 1, x2 is x1 to 1, and for a particular value of x2, x1 is 0 to x2. That's why this is the marginal PDF of x1, this is the marginal PDF of just x1 and x2 are reversed. And once you have this one, can we calculate this one? From here, from 0 to 1, x1 times 2 into 1 minus x1, and that results in 1/3. This one results in 2/3. And so the expected value vector is very silly, right? Very silly. Now the second moment. Why do we need the second moment? To calculate the correlation of Rx, what we need the expected value of the second moment, expected value of the product of x1 and x2, then expected value of the product of x2 and x1, and the expected value of x2 square, right? So we calculate just replacing x1 by x1 square, this one 1/6. We calculate x2 square by replacing x2 square. And then what we need? The correlation of x1 and x2. The correlation of x1 and x2 is found multiplying the joint period, second to part, limits will get 1/4. And so the Rx will be what? A matrix. What is the matrix? 1/4 will be here, 1/4 will be here. This one. And half, 1/6. 1/6 will be here, half will be here. Do you understand? Any covariance? What is mu x? 1/3, 2/3. Then this one will be 1/6, 1/4, 1/4, half, right? Minus this will be right here. Up. Look at this. Then it will be the covariance is right here, right? Before we leave, let me show. The cross correlation and cross correlation. What is cross correlation? If we calculate the correlation between two random vectors, then we call it. Earlier one that we considered as correlation or covariance, it was autocorrelation. If it is with itself, then we say it is autocorrelation or autocovariance, and if it is between two random vectors, then we call it cross correlation. Basically, there are some extension of this you will learn. So the cross correlation between two random vector x and y, just reconsider the correlation of x is what? Expected value of x times x transpose. And here it will be x times y transpose. And covariance is this one. dimensional vector and y is a derived random vector. Y is x plus x is multiplied by a matrix and added with the vector. Right? What do you mean? Okay? So what are we discussing?
PTTC.
Hold on. What can enter the combination here? Only 20 students here. Can we just 60 sounds science subject?
Very well.
How many? Higher than the number of students that are present in the study school. 49, here 5, 6, 11, 15, 18, 21, 25. Who are those 24? So I can give you the attendance sheet again. Those who have signed for others, please find it. At least that will be better, right? So who have signed for others? For example, the last rows are international students, right? Starting from 57. Is he here? 58. 59. So who signed for him? It should be 3 of you. Then 62. Who signed for 62? Who signed for 63? It should be 3 of you, right? 65. Okay. And 67. So, you signed for you? I signed? Did I sign? Yeah, in this place. Who is Nafis? 45. The signature indicates it was not signed. Who signed for it? So, these extra attendance that you have given here, I actually owe you. And when will I collect it? At the day of judgment. Okay? You know what is the day of judgment? So, let me know the good people. Who are the good people? Okay. So 4 is here.
Yes, sir.
5, 6, 7. Who signed for him? At least you should have the cards. 8. 8 is here. Oh. 9. Dion. Now ready. Then Nashat. Then 12. Zikr sir or not sir. Maybe yesterday he was not. Then 14. You are present what? 17. And it is under He himself underlined. 18, 19. খুঁজে বের করছে আগের কথা থেকে বলছি বুঝলেন কেন এখানে তো ছিল না সো 20
প্রেজেন্ট স্যার
22 3 23 সিগনেচারটা ঠিক মতো করতে হবে 24 আগের দিনও আসেনি 25 26 27 28 29 30 31 32 33
Yes, sir.
35
Present, sir.
6 36 signature of one is only question 37
Yes, sir.
38 so the count has to be end of the day you cannot double present right I'll count again 39 40 42
Yes, sir.
43 45 46 48
Present, sir. 40.
49 50
46 was there.
huh
46 was there.
46 K because there are only one student okay as you are certified so otherwise you know what the day of judgment so 48 is here right you are 48 and 50 51 52 53 54 55 56 দেখি মনে হচ্ছে আগের দিন ওই সাইড 57 so 1 2 3 4 5 6 7 8 9 10 11 12 13 14 15 16 17 18 19 20 21 22 23
স্যার একজন ছিল পরে
ধরে So out of 59%, according to the document, 23 are down to call. So each of these students signed for 100%. Each of the marks that you will get if I just cut it to half. Because you doubled it. And to make it fair, I need to do that. So this is our actually national character. Whenever you will be on the road, the cars that are actually besides you, there will sometimes be a situation where actually